Hello, this is Walker Physics, 4th edition, and we're in Chapter 7 on work and kinetic energy, and we're in the end of the chapter questions number 22. The work, W sub 0, accelerates the car from 0 to 50. Is the work required to accelerate it from 50 to 150 equal to twice that original work, 3 times, 8 times, or 9 times the original work? Okay, so we don't have a zero, so we can't just say 1/2 mv squared. We have a final velocity and an initial velocity, so that means I can find out the original because it's 0. So the original work is going to be 1/2 times the mass times the square of the velocity. Okay, that's when this v actually has to be v sub f. And I don't have to subtract anything because the original is 0. In the second one, I do have two parts. It has to be 1/2 mv squared final minus, I do it again, 1/2 mv squared initial. Okay, because this one I'm starting at 50, I'm not starting at 0. So the first one is going to be 1/2 times m times 50 squared. So the work is going to equal what? 50 squared divided by 2 is 1250 times your mass. Okay. The second one is going to be 150 squared. Let me go ahead and put it 1/2 m times 150 squared minus 1/2 m times 50 squared. This would be the work of the second guy. So 150 squared divided by 2. So this is going to be 1150 m minus, was it 1250? So we just did it. So 11250 minus 1250. The work equals 10,000 joules, or 10,000 m joules. 10,000 joules times the mass. So we want to know how many times bigger is 10,000 than 1250. Okay, 10,000 is how many times bigger. So divide by the 1250. We're going to take the 10,000, divide it by the 1250, and we'll see how many times bigger that is. And it equals 8. So your answer is going to be 8 W sub naught. Okay, so we're going to have a bigger formula whenever you don't have a 0 initial velocity. We have a smaller formula whenever you have a 0 velocity because this whole second part would simply just go away. So I hope that's a little that's pretty cool. Oh, and we never did the question. Choose the best explanation from the following. Okay, this is tough. This is a tough question. So if the number one looks good, but it doesn't seem, I don't think it's good. The work to accelerate the car depends on the speed squared. Well, you can see that work does have a square of the speed, v squared, but the work, remember, is the difference between this and this. Okay, the work is the subtraction of those two, and each of those would be squared. All right, so this one is, let's say that's W sub O, 50, and this is 3 times 50. So 3 times, let's just say 3x. 3x would be 9, so this would be 9W. 9W minus 8W, or sorry, 1W is 8. That's the reason. So it's because this is 3, because the second speed is 3 times bigger, and then you subtract the original speed, or the work was 3 times bigger, you subtract the original work, and you end up the work being 8 times bigger. So we're looking for something, so the final speed is 3 times, there's your 3, okay? And since that 3 is squared, that's 9, and then since this is based upon the change in kinetic energy. So this is a kinetic energy that's 9 times bigger than this, and the change requires a subtraction. That's why you have 8 times. So I would say the answer is 2. The final speed is 3 times the speed that was produced by the work W sub naught. Okay? Tough question, I think.